Hi, let us talk about eigenvectors. And before that, I'd like to introduce the column-wise matrix multiplication. Let's say you have a matrix and you'd like to multiply with 3, 1, negative 1. Then this can be multiplied like 3 times the first column plus 1 times the second column plus 0 times, this is negative 1, right? The third element is negative 1 here. So negative 1 times the third column, that is 0, 1, 1. And you can see the result. So the result is 3 minus 1, 2 plus 0. So 2. 3 minus 2, 1. And 1 minus 1 will give you 0. And this is 0, negative 1, negative 1, negative 2. So this is the result. So you try to see the multiplication as column wise, right? The first element into first column plus second element to second column plus third element into third column. Okay. So now let us talk about an eigenvector. So when do you say a vector is an eigenvector? When you start with a square matrix, when Ax equal to some constant times the same vector. Eigenvector is a vector, it remains in the same direction or in the opposite direction when you multiply with that matrix A. That's what the eigenvector. So Ax must be equal to lambda times x. So now let's say if you want to verify whether a vector is an eigenvector or not, you just multiply A with x and you see the result. If it is a constant multiple of x, yes, you say it is an eigenvector. If not, no. Okay, to see this, here is a problem, like this is one of the gate problems. Now consider the matrix M and one of the eigenvector of M is, anyway, definitely only one option is correct. You can see that M times the first option, that is 1 times the first column plus negative 1 times the second column plus 1 times the third column. So when you add it, what is the result? I get 2 here because 1 plus 1, 2. Next 1 plus 2 plus 1, you'll get 4. Next 0, 1, 1, 2. And you can see that this is not a constant multiple of this vector. I mean n times 1, negative 1, 1. This gives us 2, 4, 2. Now can you express this 2, 4, 2 as a constant multiple of 1, negative 1 and 1? Is it possible? Let's see if it is possible, then k must be equal to 2 from the first entries, right? From the second entries, k must be equal to negative 4. How it is possible? How k can take the two different values? No, therefore it is not an eigenvector. Now look at the second option, 1, 1, negative 1. And you can verify that this also will not give you a constant multiple of that. Okay. But when you multiply with the last, option, so that is 1, 1, 1, it is same as, see, remember one thing, multiply with 1, 1, 1, it is same as taking the column sum, that's it. First column plus second column plus third column. So what is the column here? First column sum is, the first entry will be 0. The second entry 1, negative 2, 1. When you add it, you get 0 and the result will be 0. So now m times 1, 1, 1, which gives us 0, 0, 0. Now can you write it like constant into 1, 1, 1? Yes, it is possible. I'll take that constant to be 0. So 0, 1, 1, 1. See, remember one thing. Eigenvector is not a 0 vector. But you can have a 0 eigenvalue. Don't get confused with that. Okay. So an eigenvalue can be 0. But eigenvector cannot be a 0 vector. So it is clear that 1, 1, 1 is an eigenvector and 0 is the corresponding eigenvalue. Okay. And you may say one thing, sir, here it is given as a last option, so it will take time to do. Yes, definitely. Why? Because once if you verify first option, second option, third option and the last option, then definitely it takes time. But you can do one thing. Uh, Whenever you are given with a matrix, you always observe what is its row sum. It means sum of the entries in its row. Suppose if you came to know that sum of the entries in a row is a constant, that constant will be an eigenvalue and the corresponding eigenvector is 1 1 1 1. Okay, let's see. See here, I'll create a matrix like this: 1 2 3 3 0 3 4 1 1. Now this is the matrix, and if you ask me one of its eigenvalues, first let me observe this matrix. You look at the sum of the entries in each row. Sum of the entries in each row, you see this is 6 and this is 6 and this is 6. So the row sum is equal. Row sum is equal to 6. So therefore definitely 6 is an eigenvalue. Now if you ask me what is the corresponding eigenvector, the corresponding eigenvector is nothing but 1 1 1. Why? Because the moment, if I take this one as a multiplied with 1 1 1, it is same as adding all three columns. So when you add the columns, you get 6 6 6, and this will be 6 times of 1 1 1. That's it. Therefore 6 is an eigenvalue, and the corresponding eigenvector is nothing but 1 1 1. Okay, so I hope you understand. And one more thing, suppose if the column sum is same, let's say you have a matrix, but anyway let us observe here, the row sum is equal, but if you look at the column sum, this is 8 and this is 3 and this is 7. It is not equal, so I cannot make any comment on it. Okay, next let me take another matrix, A equal to 1 5 negative 1 and 2 3 0, next 1 1 and 3. So this is the matrix I am taking. Now if you look at the row sum is not equal. Why? Because the first row sum is 4, second row that is 9, the third row which is 2. But look at the column sum. When you look at the column sum, the first column sum, this is 5, the second column sum 5, third column 5, third column sum 5. But now what you can say is 5 is an eigenvector. 5 is an eigenvalue of A. That's all I can say. Why? Because we know eigenvalues of A and A transpose both are same. You will not have different eigenvalues. Why? Because you know determinant of A and A transpose are same. That implies characteristic equations are same. It means the eigenvalues are same. But remember, but not the eigenvectors. So all that I can say is 5 is an eigenvalue of A. If you ask me what is the corresponding eigenvector, there is no way I have to go for investigation. It means we have to go with the procedure. You need to see the solution of A minus 5 times I multiplied with x equal to 0. Okay, but I can say one thing. I cannot say what is the eigenvector of A, but I can tell you what is the eigenvector for A transpose. Because the moment you take A transpose, rows becomes columns. I mean, these columns becomes rows. Now the row sum will be equal to 5. So whenever the row sum is constant, you know that 1 1 1 is always an eigenvector. So what I know is A transpose multiplied with 1 1 1, which gives me 5 times 1 1 1. So when you know the column sum is equal, then you can talk about eigenvector of A transpose and eigenvalue of A and A transpose as well. Okay, but when you know the row sum is equal, you can say that row sum is an eigenvalue and 1 1 1 will be the corresponding eigenvector. Okay. Now let's think. Look at few more things. So here, this time I'd like to create a matrix 1 2 1 0 5 3 1 negative 1, negative 2, negative 1. Okay. Yeah, here neither the row sum is equal nor the column sum, but there is something you can observe. You look at the first column and the third column. When you add the first column and the third column, you will exactly get a zero column, isn't it? Now you can see that 1 0 1, the job of this guy, a multiplied with this guy will make, will add the first column and the third column. That's what exactly it will do, right? Isn't it? So now what is the result? The result is nothing but 0 0 0. Now can I write it like this? 0 times 1 0 1. Now you can see that when you know the sum of the first column and the third column is 0, then definitely 1 0 1 will be an eigenvector and the corresponding eigenvalue is 0. Not only the row sum, when you know the column sum, and here we must be careful. When it is constant, when the sum of the two columns is constant, I cannot make any comment. If it is 0, yes, you can proceed. Why? Because the first column, third column, when you add it, you got 0. That can witness 0 times of something. Whereas suppose if I take 1 2 1, 0 5 3, 1 2 1. And when you take it here, but the first column minus the third column will give you 0. It means 1 0, negative 1 is an eigenvector this time, and the corresponding eigenvalue is 0. But I don't want to take the same. Let me take little different. 1 and it is 3, 2 2 1 and 3. Now you take the sum of the first column and second column, which will give you 4 4 4. So the sum of the first column and the third column is constant, but if you observe that if you multiply with 1 0 1, you'll get this 4 4 4, but there's no advantage to me. Why? Because I cannot write it as 4 times of 1 0 1. It is actually 4 times of 1 1 1. Okay. So when the sum is 0, or when like one column, it's a constant multiple of the other column, then you can say that 0 is always an eigenvalue, and you can find what is the corresponding eigenvector. Okay, I hope you understand, and let me know if you have any questions or doubts, so that I'll make another video if you have questions on it. Okay, thank you. Bye.